you don't realize they're a big part of your life until somebody starts talking about the idea of car insurance. Okay, anybody asking how much your parents pay for your car insurance for you to drive that vehicle? Anybody ask? Okay, once again, males, it's probably about anywhere from $100 to $150 a month for you to have car insurance. For females, it's probably about anywhere from $90 to $110. But those all change. When you get a speeding ticket or you've been a part of an accident, I know, Mr. Clark put it there. I saw it up there. I just can't reach it. I'm too short. Um, the ramifications of you getting a moving violation, whether it's running through a stop sign, whether it's getting into a car accident, whether it's a speeding ticket, those affect your car insurance, because if you have those things on your record, that's showing that you have a higher likelihood, a higher probability of getting into a car accident. And once again, if you get into a car accident, that's when car insurance companies reduce their profits. They reduce their profits because they're always going to make money. They won't lose money, they'll just reduce their profits. That's when they have to pay out. If somebody gets into a car accident, if you get into a car accident and you really hurt somebody in a car accident, it could be $100,000, $200,000 that the car insurance is going to have to pay out. When it comes to medical bills, possibly the person could be injured that you hit in the other car, cannot work for the rest of their lives. So what the insurance company must pay is the wages of that person for the rest of their life. Whatever they would make for the rest of their life, maybe $80,000 a year, they have to pay for that. They have to pay that. Which, if they still have 20 years to work, that's $1.6 million that the insurance company has to pay because of the person's loss of wages for the rest of their lives. And what happens is, if your car insurance only maxes out at a certain level, what they'll do is they'll start coming after you, and you'll have to pay out of your own pocket then at that point. So if you have a driving record, you are showing that you have the ability to drive at a higher rate, which decreases your reaction time, which also increases your opportunity or your likelihood of getting into a car accident. That is a huge thing in regards to what affects you. But every company, every business, Smuckers, has people that sit there and look at statistics all the time. Smuckers used to be just jams and jellies and goober jelly. That's all they used to make. When I grew up, it was great when the wind was blowing out of the east, because the factory over there was making strawberry jelly, and this odor, this quaff of strawberry jams would go over the whole city of Warville. And it smelled so good. When we get the east wind in Downton, what do we smell? Dog food. We smell Purina down there. Not quite the same flavor as the strawberry jams and jellies, but that's what they used to only be. Smuckers now owns Folgers. They own Purina. They own I can't remember what all they own. They own the dog food thing. They own coffee. They own all these other things. Why did they buy these other things? Well, statistically, what's going to happen with them, they saw an opportunity. They did all the research and they did all the statistics, and they saw that if they purchased these entities, they would be able to make more of a profit. They would make more of a profit. And they look at the bottom line, how much profit that they can make over there. So all of a sudden, there used to be a little White House out here. Little White House on the other side of the Board of Education office. There was a house over there that was their office building that looked like that. And back behind, it used to be one small plant that was back behind that made all their jams and jellies and their goober jelly. And that's all it used to be. Now it is a metropolis over there, and it's amazing how you have a small little village within the city of Warville. Okay, it used to never be like that. It used to be a small house. My mom used to work as a tour guide for Smuckers. And she would, people would come in and she would walk them through where they're making jams and jellies and where they would make the jams and jellies at. People would come in just to tour the village or tour the plant over there. That's what my mom did. But she lived they worked in this little house, and that was their main office, their main floor. And then the second story was for the higher up people. That was it. So statistics are part of everything that we do mathematically, everything in part we do in our life. Okay, you are a statistic, as we talked about before. We talked about gathering data here. This is data that was gathered 10, 15 years ago about the likelihood of being a high school athlete and making it to the professional ranks. We talked about a population. Population is an entire body, a group of people that you're trying to study. A sample is a smaller set of that people because most of the time we can't study an entire body. The presidential elections, once again, we talked about this the other day, presidential elections. They do all these surveys. They start doing surveys a year, 2 years prior to presidential elections. Once they know the candidates, they start doing surveys. Who are you going to vote for? Who are you going to vote for? And they start trying to forecast out who's going to become the next president of the United States. And how they do that is they don't poll everybody in the United States, but they poll 2,000, 3,000 people in the United States. They call them up and say, hey, who are you going to vote for? Who are you going to vote for? And they start getting data in regards to what people are going to vote for or who people are going to vote for. So they take a smaller amount, and it makes it a lot easier because the time it takes to do the entire population is difficult to do. But what we do is we look at a sample to estimate what the population is going to be. We talk about a parameter. We talk about a parameter in statistics. A parameter is a numerical description about the population. P goes with P. We talk about a parameter. It's talking about a population. We talk about a statistic, and that's what this class is. It's a numerical description about a sample. So we talk about a parameter. It's a numerical description about a population. And that's what we try to estimate. To estimate that, we use a statistic, which is a numerical description about a sample. So S goes with S, P goes with P. Population, parameter, sample, and statistic. Statistics, what it is a science of conducting a study to collect data. You collect the data first. You organize it. You analyze it, and you draw conclusions from the data. That's what statistics are. And we will go through those entire steps, all those steps, as we go through this entire class here. We're going to collect data. We're going to organize it. We're going to analyze, and we're going to draw conclusions. Most of the time when we collect data, though, when we're collecting it, it's already going to be given to us. We're going to be mainly looking at organizing and analyzing and drawing conclusions. The year-end project, we'll do a project in the middle of May to finish out the school year, and you'll be going through all those steps. You'll be developing a question. You will go collect the data. You'll organize it, you'll analyze it, and you'll draw conclusions from your guess. What you'll do is you'll make a question and you draw a guess from it. Two different types. You have descriptive statistics. You have descriptive statistics, and that's exactly what it is. When you have descriptive, you're describing something. It consists of collection, organization, and presentation of the data. Tries to describe a situation. Consists of collection, organization, summation, and presentation of the data. It tries to describe what is going on. And that's called descriptive statistics. And then we have inferential, which consists of generalizing from samples of populations, performing estimations, and hypothesizing and hypothesis testing. Determining relationships among variables. The inferring of things. Generalization of samples to populations, performing estimations, and hypothesis testing. Determining relationships among variables and making predictions. When you do your fantasy football leagues, when you do your FanDuel, stuff like that, they gather up the data, how a person has performed. How a person has performed throughout the entire year. How the person and what team are they playing against, and what are they good at and what are they not good at. And then they make predictions about what the possibility of the player could actually score in regards to fantasy football. That's all dealt with statistics. When you deal with the idea of fantasy football leagues and stuff like that, or any fantasy sports, you're dealing with a lot of statistics that are gathered. And they make predictions. Talked about this a little bit the other day. Who do we gear commercials to on the Disney Channel at 9 a.m. in the morning? Well, statistically showing who's at home and who's watching those shows. Those are 5-year-olds, 4-year-olds, 3-year-olds. You have 3, 4, 5-year-olds here. Compared to at 7 p.m. Okay, after homework is done, who's watching Disney Channel at 7 p.m.? First graders, second graders, third graders, up through 6th grade probably, maybe 7th grade. Now up through 7th grade, maybe a little bit of 8th graders. By the time you make it in high school, we don't really tend to go into the Disney Channel anymore. Okay, we're not really watching, anything that's going on there. But you're usually up to about 7th grade. So every one of those commercials that are on Disney Channel up through 7th or at 7 p.m. steers towards that age group. Okay, the next new gadget that's out there, the next new iPhone that's sitting out there. Okay, all those ideas, makeup, dealing with makeup, things of that sort. Those are the things that are there. Why? Because that whole generation there, all those grade levels are starting to emerge into those little, into those categories of what are they going to buy. Okay. Once again, all statistically driven. Once again, as we talked about, typically those commercials are going to gear towards moms a little bit too, because those are the people that are sitting at home. If children are at home, moms typically are there. Not always, but typically are the ones that are there, that are going to be in earshot of the TV. So I'm going to make sure that mom hears what's going on TV. They can also hear a commercial. We talk about data. Is values, measurements, and observations. Datum is a single data value, and a data set is a collection of all your data values. Datum is a very little used term. Most of the time, if you have one single data value, you just say I have one data value. We have two types of variables. We have a qualitative variable. Once again, this first week of statistics, I'm not a huge fan of, just because we have to go through a lot of notes. But we have to have some sort of basis of vocabulary as we go forward. Qualitative variables, variables that can be placed into distinct categories according to some characteristic or attribute. Examples: what county a person lives in Ohio, what school do they attend. Variables that can be placed into distinct categories according to some characteristic or attribute. What is the religion of a person? Are you male or female? Some qualitative, some sort of quality of a person. What's your eye color? What kind of car do you drive? If you drive. That is a quality of a person. It's a qualitative variable. County do you live in the state of Ohio? What school do you attend? What college do you attend? Are you going to college? You have two different types. You have a qualitative variable, that's a quality, and then you have what is called a quantitative, which is a quantity. Numerical values that can be ranked. Numerical values that can be ranked. The height of a person, the age of a person. Numerical values, a quantity. How much does a person make on a yearly basis? Those are all quantities. You talk a quantity, any type of quantity, any type of numerical value. Anything that can be measured. You have two different types of quantitative variables. You have discrete, which is exact amount values. Things that can be counted or countable. Things that you can count. Those are discrete. How many people are in this class? How many people are eating lunch today? How many people are absent today? Number of children in the family, number of students in the classroom, number of text messages you received today or sent out. You can count them out. What was your screen time today? What's your average screen time? What is the percent of your battery right now? What's your longest Snapchat streak? How many followers do you have on TikTok? How many people do you follow? All those data values can be gathered up through your phone. They keep track of all that. You may not see it at times, but there is somebody that knows exactly everything about how many Google searches you've had on your phone. That could come up. You could find, there's not somebody sitting there counting them, but you could go to an entity in Apple, if you have an iPhone, and they can, or your Verizon or AT&T or whatever, and they can come up with all this stuff. Okay. You are not anonymous. Your parents can find you. Unless you turn your phone off. And then they're going to say, well, you turn your phone off. Why'd you turn your phone off? Where are you at? What are you doing? Oh, believe me, there's accountability, and you're not anonymous anymore. Big Brother can find you. If they want to find you, they can find you real quickly. All they have to do is they have to find your Verizon account or your AT&T, whatever you have, whatever your carrier is. They can go to that account. They can find your phone number, and they can find you. So if the FBI wanted to come find you right now, there would be somebody here within 5 minutes. If they wanted you, they could find you real quick. Big Brother. I'm not a conspiracy theorist. I'm just telling you, Big Brother can find you. And you can think about all the Alexas, that are in your house or your whatever you have. There is videos that are out there and documentaries that are out there about everything that occurs with Alexis. Now that's conspiracy theory. You also have continuous. Yeah, continuous can assume an infinite number of numbers of values between any two specific values. They are obtained by measuring and often include fractions and decimals. They can assume an infinite number of numbers of values between any two specific values. They're obtained by measuring and often include fractions and decimals. These continuous variables always occur when you're dealing with measuring, because you can only be as accurate as the biggest place value that you're measuring to. Not feeling well, so you stick a thermometer in your mouth until it goes beep, 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 and then you pull it out. What is a normal body temperature?
98.6.
98.6. And you pull out, it's 98.6. But do you know if it's exactly 98.6 on that thermometer? Or could it be 98.6, 1, 2, 3, 4, 7, 8? Could be. Or it could be, 98.5997998. Not exact, but it rounds to 98.6. Okay, so when you're dealing with measurements, whenever you measure, you're only as accurate as the largest place or smallest place value that you have there, which is the nearest tenth on the thermometer. Temperatures between 40 and 41 degrees. How many temperatures do you have between 40 and 41 degrees? Well, you have an infinite number of temperatures, because you have an infinite number of numbers between 40 and 41. So mathematically, when you're in statistics class, yes, we do a lot of mathematical computation in statistics class. For the University of Findlay, statistics is a math class. You go to big universities, University of Akron, you have a mathematics department and you have a statistics department. Mathematics teachers don't teach statistics. Statistics teachers don't teach mathematics. You have two different departments. Statisticians are not mathematicians. Mathematicians are not statisticians. Yes, do they have to do things together? Do these statisticians do these mathematically things? Yeah, they do. But if you're a statistician, don't call me a mathematician. If you call me a mathematician, don't call me a statistician. Okay, and they get a little rankled about it. They do. It's like they have a throwdown. Don't be calling me. This is a math class. This is a statistics class. I'm not a math teacher. I'm a statistics teacher. And they get, like I said, they get a little rankled about that. It is two totally different groups. So there's certain things that we will do that will not jive to mathematicians. And this is one of them right here. A specific measure can be 1/2 unit, the next smallest unit in either direction. Okay? 1/2 unit to smallest unit in either direction. So we're going to talk about what is called boundary values. If you measure something to 27 kilograms, you have boundary values that are 1/2 unit in each direction, which is 26.5 and 27.5. Those are called boundary values. Now, I know you're going to sit there and say, well, 27.5 rounds up to 28 if I use mathematic rules. And that's why I've always learned mathematically. I look at the next decimal value, and that tells me if it's 5 or more, I round up. If it's less than 5, I round down. In statistics world, I use these as boundary values. I'm not rounding. I'm just using them as boundary values. When we have a decimal in there, this is where it becomes a little bit more difficult to see. I look at my next smallest unit. Okay, I have 21.3 as 3/10. Hundredths is my next smallest unit. So I have to go 5, 1/2 unit more, 1/2 unit less than this 30 or the 0. So my boundary values is 21.25. Think of this as 30. I subtract 0.05. I subtract a nickel. And 21.35. Because this is my next smallest unit, I go 1/2 unit of that, which is 5 in either direction. Once again, you sit there and say 21.35, that rounds to 21.4. No, in the statistics world, these are just boundary values. They're not rounding, they're just boundary values. We'll start this, we won't get through this all. We have levels of measurement. We have what is called a nominal level of measurement. A nominal level of measurement, which is data that are categorized using names, labels, or qualities. A nominal level of measurement. Data values that are categorized using names, labels, or qualities. This is a qualitative variable only. Use no mathematical computation. The color of the cars in the parking lot. What's the color? Color of a person's eyes, color of a person's hair. Equality. No mathematical computations with a nominal level of measurement. You're dealing with a measurement, but you're just measuring a quality. You're tallying up qualities. I'll just do this last one here and then we'll be done. Leave the rest for tomorrow or Tuesday. You have an ordinal. You have an ordinal level of measurement. And when you talk about an ordinal level of measurement, classifies data into categories that can be ranked. There's no precise differences between the ranks. This could be qualitative or quantitative. So an ordinal classifies data into categories that can be ranked. No precise differences between the rankings, though. Be qualitative or quantitative. The floats in the parade were ranked as first, second, and third. Well, what was your measurement? That one looked nicer. That was a little bit more towards the theme. All right, let's give that one first. Well, what was the difference between first and second? Well, that one wasn't quite as nice. Okay. Classifies data into categories that can be ranked. No precise differences between the ranks. You run the 2 mile on the track meet or a mile on the track meet. 4 laps around, 8 laps around. You go the 8 laps around, 2 mile. Okay? You're doing the 2 mile out there. Person finishes first. Person finishes 3 seconds behind them in second place. Person finishes third. They were half a lap behind that. So it's another 40 seconds before they come in. But they still got first, second, and third. Doesn't matter that it was only 3 seconds between first and second. It was still first and second. Third place got third place. Why? Because they were 40 seconds behind number 2. There was no precise difference between the two. We'll deal with the last one on Tuesday and the last 2 on Tuesday. And we have one other set of notes that we have to go through on Tuesday. And then we'll be done with chapter 1. Okay, once again, you get to talk about statistics, but I like when we get through chapter 1 because I like doing math a little bit more. Questions?